Hello, everyone, and welcome to the 12th episode of CPP Next. In this episode, I will give you a small taste of what does it mean to use ranges that are with us since C++20. So what are ranges? Let's say that we want to create a list of numbers, or basically a range of numbers from 1 to n. Afterwards, we want to take only the odd numbers from this list, or range. Afterwards, we want to take only 10 first numbers from this list. And then we want to reverse the order. You must ask yourself, how hard was it to write something like this in C++ before C++20 and ranges? So let's look at the code. Well, I don't know about you, but that's a lot of code to write to execute something as simple as what we wanted here. Let's go line by line and try to understand exactly what's going on in this code. So in line 9, we're creating a new vector with 30 numbers that's called iota. Then we're creating a lambda that will be our predicate to calculate only odd numbers. Afterwards, we are calling the iota function from numeric library that will just create all numbers from 1 to 30, and it will populate the iota vector. Afterwards, we are creating a new vector called temp. We are reserving 20 numbers to it just to make it a little bit faster. Then we are using the copy if algorithm from iota, from the beginning of iota vector to the end of the iota vector. And we are populating our new temp vector from the beginning. And we're using our predicate function. Afterwards, we're creating another new vector that will copy only the first 10 numbers as we requested from TMP vector. Afterwards, we're using the reverse algorithm, the in-place reverse algorithm. And afterwards, we're using the FMT print function. And the FMT print function saved us a couple of lines as well, because if we had to use stdc out, we will have to do all the algorithm of the printing by ourselves. And that's a lot of work. Frankly, I don't like it. Let's look how it would look with ranges. Now, this is nice and cleaner, right? We had to write less lines of code, and we wrote something that looks more like a mathematical equation than something that we had to write as a programmatical thing, right? It looks more like Python than C++, but on the other hand, it's easier to maintain and easier to read. Let's look what happens here. In line number 10, we're still creating a lambda that will be a predicate or a filter, which is better to understand with the readability. We want to filter the numbers. In line 11, the magic happens. We're creating a view. We're telling it directly that we want a view of numbers from 1 to 30. Afterwards, with the pipe operator, we are saying the numbers that are created have to be filtered with the odd function. Those numbers that were filtered and provided with the odd function, we want just to take the first 10 numbers from that, and afterwards, we want to reverse those numbers. Of course, in line 16, we just printed exactly as we did it before we had ranges, but still, look at this. We got the same answer in an easier way. And the magic with the view is that it's lazy. That means in line 11 to 14, nothing happens. And the numbers are starting to be pushed from the iota to the reverse just in line 16, because in line 16, we're actually printing it out. And because we're printing it out, we're starting the process. So how cool is that? Now you're probably asking yourself, what about performance? So let's look here. We have our function that is used with iterators, just as we used it before we had ranges. And we have the ranges function that uses ranges. But look here, I told you that nothing happens in these lines. And we can see it in performance as well, because nothing happened. We have a huge performance hit, but that's not right. We have to write something for this range to be used and produced, and only then we can see the difference in performance. So let's do that. So basically, we need just to trigger something to work with views, or basically to trigger the range. Let's use for each from ranges library. But what happened here? Still, we have nothing in ranges. That happens because the compiler has more knowledge about what's going on here, and it sees that it's basically doing nothing. And that's why everything is optimized out. Luckily for us, in Google Benchmark, we have a function that's called do not optimize out. We will use this function to get what we need. And voila, as you can see, we have a performance for our ranges now because we told the benchmark not to optimize it out and to do it in any case. As you can see, the optimization is much better here, and we are working 2.6 times faster than with iterators. It will not be always the case, but usually with compilers becoming better and better, the performance for ranges is becoming better and better as well. And we have more opportunities for optimization. That means we should start using ranges. They will be as fast, faster, or a little bit slower, but still the readability, if it's something that we can endure, the readability is much, much better. And we should use it for the sake of maintainability and readability. Thank you for watching. Like and subscribe, and I will see you in the next episodes.